Actually,
by the MC.
Actually, my role in all of this is, today is, I'm going to be Ed McMahon to Johnny Carson. So, that's right, a lot of people probably don't know who Johnny Carson was. Yeah, I think this group probably does. As Mike said, I've been building airplanes. People ask me what I do for a living. Sometimes I say I just make stuff. And if you make enough stuff, you can put an airplane together. And so I spend my days making parts. But John and I are building, we're each building a Fuuka D.VII. As many of you may know, I'm building one for the Fantasy of Flight Museum in Orlando. And my commission was to build an airplane as accurately as I could build it. The Fantasy of Flight Museum had a Mercedes engine, and they wanted an airplane for it. And so that's where I come in. And so I wanted to build a really accurate reproduction airplane to do the museum justice, and it has involved doing a lot of research because there are no original drawings left for the airplane, and fortunately there are some original airplanes left. And so John and I have been working together on trying to put together as much accurate information as we can on the Fuuka D.VII. And so this little talk today is a little bit about some of our trials and tribulations of trying to get the airplane right the first time, as opposed to my Fuuka triplane. I started building that airplane in 1978, and in some ways I'm still building it because I keep making changes to it. Every time I find some accurate information, I try to make the airplane a better product. So with this airplane, I only have one chance, and so we're trying to get it right the first time. And so this is a little bit of what we've had to go through to try to get it right. So here's Johnny.
Thanks, Fred. Well, Fred always makes everything look really simple, whether he's building a part or flying an airplane. And I was deluded originally when I met Fred and thought building an airplane would be a snap to do. All I had to do was work 18 hours a day, 7 days a week for year after year, and it would eventually be done. Then I'd be too old to actually fly the darn thing. What's interesting about his triplane project is that there's always new information showing up, which infers that something that Fred has already done isn't as accurate as it could be. The challenge with working with the triplane is that there aren't any triplanes out there to be able to actually go judge what you're doing against it. And there are very few drawings except for wing drawings. So when you want to make a change to the fuselage or the empennage or something of that type, you're running mostly on opinion about what is more accurate or interpretation of oblique views of slightly obscure photographs. The D.VII, it was in some ways a simpler project because there are supposed to be 7 original D.VIIs in the world. Between Fred and I, we've seen 6 of them. I've been into the archives of 5 of those 6. And part of what we're talking about is how we have actually evaluated the sources that we've had presented to us to be able to determine what we can actually use as a model of accuracy for something. When I started, this is my first airplane project, I should let everybody know. So I made probably every mistake it's possible to make during the building process. I listened to a lot of people who, as it turned out down the road, maybe I shouldn't have listened to, that sounded authoritative, but when I started looking into where their knowledge came from, it tended to be a little sort of vague about how they got to a point. And I quickly learned for myself that there was a huge number of dangerous assumptions that could be made when I was trying to build an airplane. And what I wanted to do was what Fred wants to do, is to build something that accurately reflects the technology and the flying characteristics of the aircraft in the era that it was made for. So that if somebody climbs into that actual aircraft with an original engine, the airplane will perform the way it was designed to when it was first manufactured. It won't be hampered by a modern engine, by, quote, improvements to the structure or the flying surfaces, but to try to get back to that sort of essence of what the aircraft really was. And one of the reasons for trying to do that is that hopefully after we're not capable of flying an airplane anymore or something, that albeit new-made artifact will be able to pass on that experience to somebody else down the road. I mean, I think our dream would be that what we produce is of such a high accuracy or authenticity and well documented to that state that somebody could go and look at it and use it as a source for some research that they were going to do. So these are just a quick list of the things that I came across, and I'm sure almost everybody in the audience has experienced these before. I think the one that's sort of relevant to us is the third bullet point. See if Mike's laser works. Yeah, I can't see it. I don't know how these things blind pilots. It's the third one. I have a drawing. And I've seen this so often. I've had so many drawings sent to me. When I started the project, I thought I need to get a set of drawings. And so I contacted Lou Updike at World War I Aero, who had complete drawings for a Fokker D.VII, and I ended up with drawings from 4 different draftsmen. And over the years, I accumulated other drawings from other draftsmen. Everyone professed to be exacting. The problem is they rarely, except for Charles Cash, rarely ever said what they used as a source of their drawing. And when you look at some drawings, you can see concepts, maybe is the best way to put it, carried through from one to another to another to another. Same thing goes when we're talking about replicas here. I saw something on somebody else's aircraft that I saw on exhibit. Or my favorite one is somebody told me about something that they heard from somebody else that this thing was true. What we've tried to do specifically with these projects, and I think Fred has always been doing this, is we've tried to put ourselves into the mindset of the era when the aircraft was actually built. We want to understand the engineering principles that were involved in the day so that we're not trying to rethink things from 50 years in the future with that sort of massive information that's come after the fact. We want to use the correct materials, the same materials that they used when they made it, because materials commonly used to build aircraft now, even simple things just as sheet steel, are completely different from what was accepted at that date. So I think the simplest example, because I think there's some people here in the audience who have come across this, is literally just mild steel. So if somebody goes to build an airplane now, their automatic reaction is go to Aircraft Spruce, buy 4130 sheet in the closest size to whatever it is the drawing says, and work with it. And as Fred will tell you, or anybody who's ever tried to make Sopwith SL parts, you cannot maintain those bend radii with 4130. It'll crack. You need mild steel. To get mild steel nowadays is a bit of a trick because you walk into the metal supplier and they have hot rolled and cold rolled mild steel. And if you ask for a strength report, they don't know what you're talking about. So you have to understand how strong was that mild steel? What can I use as a substitute today that will allow me to work it with the same kind of tools and techniques and come up with the same result as they did? Last thing you want to be doing is making a whole bunch of little tiny parts and you're already preparing excuses for experts like yourselves saying, well, I had to make it this way because of something or other. One of the nice sort of synthesis of working with Fred is that after a while, when you spend so much time working on the components and looking at the project as it comes together, is you start approaching problems with an understanding of how they approached them in the past, and literally trying to get into the head of the design team or the officials that came up with the definition for the aircraft.
One thing I noticed about World War I airplanes is they had a lot in common with automobiles of the era. Like for instance, a lot of the early airplanes actually had the throttle lever on the control stick. It wasn't on the side where it would be on a modern airplane. And that came from concepts of automobiles. If you've ever been around a 1916 automobile, the throttle for the car is on the control column. It's not a foot pedal. And so airplanes kind of adapted a lot of concepts from automobiles. So you know, it helps to you know, look at automobiles when you're trying to solve some kind of a problem on an airplane.
Second laser pointer. Okay, so this is pretty much standard research information here. We're trying to determine what is actually correct. I've already hammered on this a couple of times, trying to understand what the source of the information is. What's the, I mean, provenance? Where did this actual information come from? And what we all want are original sources. We want the drawings that came from the factory. Or actually, so I thought, until I started hearing stories about people building Sopwith aircraft, specifically the Camel. And it came back to me. I, at one point, trained as a draftsman in a classical day where you used ink on linen, believe it or not. And there was rarely ever a single drawing that came out of a drafting office for a thing. There would be a drawing as defined by the engineer until it hit the shop floor. And when it hit the shop floor, sometimes there was a better way to approach the item that was being made that may involve some kind of slight design to it to ease manufacture. And that came from the expertise from the people who were actually making it, as opposed to the person who made the drawing. So it wasn't unusual that there would be a drawing office, an original drawing, go to the shop floor, there'd then be a shop drawing for it. And if you were lucky, that shop drawing would get modified back to the drawing office so there'd be a revision of that original drawing. So if somebody presents you with an original drawing, quote, you don't actually know whether it's the final part as it ended up on the aircraft. It's sort of an important distinction to understand.
Yeah, let me mention something about, I have built 2 Sopwith airplanes using the original drawings. Fortunately, the original drawings exist for both the Camel and the Pup. And on both airplanes, they had the same little problem for a builder. While it's really, really nice to have original drawings, you don't have to really guess on what it is you have to make. You find that there had to be some changes made somewhere along the way when parts don't fit together. But the original drawings don't reflect whatever those changes are. Like, for instance, the wings on a Sopwith Pup or a Sopwith Camel are held on with a long rod. The main planes have brackets protruding from the wings, and they fit into a socket either on a fuselage or on the center section, and there's just a long rod that slides through all these holes that match up, and that's what holds the wing to the airplane. Well, if you build the parts exactly to the drawings and you put your airplane together, you're doing a final fit up before you cover it. You slide the rod in place and everything fits nice and tight. And you take the airplane apart and you cover it and you put the wings on, and guess what? The rod doesn't line up because they did not take into account the thickness of fabric on the wings and the center section. And it's a problem on both airplanes if you build the parts exactly to the original drawings. Well, somebody made a change somewhere along the way that's not reflected on the original drawings. Who made the change or how it's made, maybe it was just on the shop floor. Some foreman said, make it fit, And so you don't know what they actually did to make it fit. So you're just kind of guessing. But even having original drawings is not always the best situation.
Thank God I'm not making a Sopwith. So our focus is going to be on the D.VII, because as we mentioned earlier, that's the projects that we're working on. Thought we'd give a quick overview of the projects as they are. There you are, Fred. Look at that.
That's the airplane I'm doing for the Fantasy Flight Museum. And there we see some, the original Mercedes engine, and some lozenge fabric printed by the vintage Aviator in New Zealand. And it doesn't look like that now. Unfortunately, it's all painted red, but that's what the customer wants. But it actually does look pretty striking. What the airplane will be one of Ernst Udet's airplanes. And Greg, you can breathe a sigh of relief. Those stripes aren't red or black. And so that's a little bit of a look at the airplane I'm doing for the Fantasy Flight.
I always like these photos of Fred's shop. You see interesting things in them, like, ooh, look at this. There's some kind of round cowling. Hmm?
Is that the DR1?
What? I don't know what you're talking about. I deny any knowledge of that.
I had to hide the beer. I have to make it look professional.
This is like working in any kind of high security environment. You have to be careful about what you frame in a photograph. So this is the project I'm working on. You notice I've sort of focused on a part that looks more or less complete as opposed to the aircraft at all. And what I'm doing is recreating an airplane that came to Canada as a war trophy in 1919. Tail number was 8609/18. It was captured at the OAW factory to such a degree that it didn't even have national markings applied to the fuselage or to the rudder, which will make it a curious looking airplane because everybody will recognize it's not quite finished when it's not quite finished. I'm fortunate where I live, which is just north of Toronto in Ontario, Canada. And I'm fortunate for the reason that Canada has 2 of the 7 original Fokker D.VIIs. And, they're no farther away than a 7 or 8 hour drive. And of the 2 aircraft, one is a restoration that was started and stopped in the mid-1970s, and that's Fokker-built 10347 held by the National Aviation Collection in Ottawa. And the other one, which is my favorite airplane, is this one. And this is 681018, owned by the Broome County Historical Society in Knowlton, Quebec. People like Ross Walton have seen this. When he lives in Vermont, it was only a couple hours north, certainly a lot closer than I am to it. And there's an interesting story to this airplane, and the reason for the interest in the story of the 7 aircraft that are out there, this is the only one that has a virtually complete, fully documented history to it, where we can go down almost to the nut and bolt level and know what was replaced by whom and when. And that, in my mind, makes it unique to almost any historic airplane in a collection, where most of them have occasionally suffered through restorations in an era where airworthiness was more important than conservation of the original artifact. So this is how it looked a few months ago inside. That airplane has been basically sitting inside that building since 1921, when it was donated by a federal senator to his home riding. This is a picture. This is one where I say courtesy of Greg Van Weingarten. This is a picture of 6810 in the United Kingdom, probably Hounslow. And the interesting part to me is that, one, the engine's actually running, which is quite amazing. You can see that even in this day, this is either end of 18 or early 1919, it's got mismatched parts on it already. They don't fit. The personnel in this photograph are all Canadian Air Force. Canada has had so many Air Forces, it's hard to understand. They had one for about 6 months in 1914 that had one airplane that never flew. This was a second attempt, which had 2 squadrons, one of fighters, one of bombers, which was disbanded in the spring of 1919 and started at the armistice in November 1918. So this is in that brief interlude. So the airplane was actually flown in Europe, and the records for the Broome County Historical Society indicate that William Barker, VC, actually flew it there, which was actually a new fact that came out a few months ago that I was quite surprised at to find out. But, so one, we know of it being there, and this is usually where things get vague with these aircraft. Where did they go to afterwards? Some of you may remember a paper, I believe it was entitled The Canadian Fokkers, that was written by the Mike Carr Student Essay Award winner Edward Soy in 2008. And he basically wrote about the Canadian War Trophy aircraft, where they came from, how they got to Canada, what happened to them afterwards. So I don't want to repeat everything that he went over. But I worked with Ed when he was working on his thesis, and this is the little gem that we came across that was quite surprising. This is a notebook belonging to a Sergeant Mulcahy, and he was charged with the disassembly and packing of the War Trophy aircraft to ship to Canada.
That wasn't the Sergeant Mulcahy on MASH, was it?
No. Wasn't that Klinger? This is the page in reference to the aircraft, and it's wonderful. So we've got case number E9, Fokker V7 681018, the engine Mercedes 45624, Dave. That is the engine that is currently in the airframe. Seems reasonable to assume it hasn't actually been flipped in and out a few times, but don't know for sure. We just know that it's still there. We even have the magneto numbers and the ANLAS magnet, or the starting magneto number as well. I have never checked those. The starting magnet is long gone, as you'll see later. And the one thing we'd love to find that we've never seen is this reference. There's a logbook. We're assuming it's the airframe logbook when it was being flown by the Canadian Air Force in the UK, but we don't know. We've never seen a logbook for any of the War Trophy aircraft that were flown by the Canadian services. But it's something we'd like to find one day. So we've got a good history of it up to the point of May 15th, 1919, when it went to the docks. It was shipped on the SS Vesuvius, I think it was, on the 19th, went to the port of Montreal, where it was unshipped and moved by train to Toronto, Ontario, and ended up here. This is a pretty well-known photo of William Barker sitting in the Snipe that he was flying when he won his VC. And this is a hangar which was on an airfield used for training pilots in World War I called Leaside Airfield, which at the time was on the northeast corner of the city of Toronto. Standard First War British-style hangar. It's got the basket weave trusses up above, et cetera, et cetera. This Snipe, by the way, if you don't know, you can see the fuselage looking almost identical to that sitting in the Canadian War Museum in Ottawa. It is missing the sheet metal, by the way. Just to finish up with the Snipe, when it landed in Montreal, it had the Bentley engine on it. When it showed up in Toronto, the engine was gone. So all those people who were looking for a Bentley rotary somewhere between Toronto and Montreal. The other thing I like about this photo in particular is Barker has this odd expression on his face, and I'm suggesting that one of the reasons being is that we have a D.VII here, and we have a D.VII here, and we've got a D.VII here, and here. This was probably sort of a little bit of deja vu for us. There's nothing in here to indicate that 6810 is actually in the hangar right now, or it's not in the crate, but we do have records at the National Archives that shows that all the aircraft, all the War Trophy aircraft, were transshipped to this location. The government had no place to store them, so this fellow, Erickson, if anybody is up on Curtiss Aircraft background, Erickson was an employee of Curtiss Aircraft and ended up as the manager of the nationalized Canadian Curtiss, which became Canadian Airplanes Limited, that built Jennies. Somehow, miraculously, at the end of the war, somewhere around January 1919, this manager was able to come up with a neighborhood of $500,000 to buy all the surplus aviation assets from the Canadian government, including the airfields. There's a story there for somebody. This is the Broome County Historical Society. This is their first building. They have 5 now on location. And at the very back of it, you can just see a corner is the Martin Annex. And when the airplane was shipped there in 1921, a local citizen volunteered the money to build a building to put it inside. The airplane has been basically inside that building since 1921, when the building was opened by officials from the Canadian government. The only time it's been out of that building, it was in very late 1962 into 1963, when the RCAF took charge of it to put on display for an Air Force Day. And the aircraft was deemed to be in need of some minor restoration to make it more presentable. And this is where the horror story would normally start, is that, oh, we gave it to the Royal Canadian Air Force to, quote, fix up, you know, with a spray gun and stuff. They took a hugely different approach to this, as they didn't restore the airplane, they conserved the airplane. They conserved the airplane to a degree that they worked with the National Gallery in Canada to try to understand how to deal with old linen based on the conservation approaches used for sort of cloth-based paintings. This document here is only one of numerous work records that we have access to, which define in boring detail every single step that was taken on the airplane, what they did to every single part of the airplane. Because of these records, we can now determine what was changed by the RCAF and what was left alone. So that's the reason for selecting the Knowlton airplane as our primary source. There is one huge caveat in this. Statistically, we're using a sample of 1. Okay? And the reason being is that it's the only sample we've been able to find where we can really have confidence in that when we say that this was on an Albatross built Fokker D.VII, that it's accurate. So be careful. What we're saying here applies to Knowlton 6810 with all its warts and everything else, and isn't necessarily universal common in Fokker D.VIIs. So we're going to go through 4 examples of projects that we've undertaken where we've tried to resolve a challenge by using research to be able to work it out. So the first one is my favorite. It's deduction by direct observation. I'm not a trained researcher by any means, so I've made up all these terms, okay?
They sound good anyway.
Yeah, thank you very much.
Very impressive.
So this is my favorite. It's the mystery of the missing gauge. You can see we're calling it part 1 because there is a part 2. This is 6810's panel, and there's things missing in it. Now, the first thing that's missing over here is this is where the connector block on the back of the System 1 Bosch hand crank starter magneto goes. The second opening up here is where there was an air pressure gauge. We know that because I've been allowed a huge amount of access to this airplane. I've been allowed to take things off it, which people haven't done knowingly for a long time. We've been able to inspect the back of the panel. One of the reasons for doing that is because when the panel was made for the Fantasy of Flight's D.VII, we wanted to make sure that it was plumbed the way an original was, and this is the only original we could find that still had the 4 block of valves, so we could know it. And one of the valves, you can't really see it up here, it says manometer on it. That one actually selects about whether the pressure gauge is reading from the main tank or the reserve tank, or it allows you to bleed off all the pressure from the system, which is part of the shutdown process. And there is a single 1/8" copper pipe coming out to it with a connector to feed into the gauge. So even though there's no actual gauge there, we're pretty confident that's what that hole was. The mystery is this hole. big hole. Doesn't show up on most drawings, though it has shown up on a couple of sketches in World War I aero. Don Dodson did one in the late 80s in an issue of World War I aero where he just showed the drawing with no comment about what the hole was. And I've heard lots of people make suggestions, but nobody come up with anything really definitive. And that's the whole story. So this is Memorial Flight's BMW-powered D.VII. This is a reproduction aircraft, very exacting, done extremely well. And you can see inside the panel, they have this item here. Looks like an artificial horizon, but it's actually an early turn and bank. And I was fortunate to be able to go to Le Bourget and meet with the people at Memorial Flight and hang around for a day. And when we finally talked about this, well, they said, well, there's a hole in the panel of the Knowlton airplane. We're pretty sure this is what should go there. I think that was based on the fact that they had a gauge. and I don't know that for sure. I'm not fluent in French. But I thought, well, that's interesting. But from our perspective that Fred and I are taking of this being an artifact that somebody looks at 50 years down the road, is this going to mean that everybody's going to think that there was an early turn and bank in a D.VII panel? Well, to compound things, Wingnut Wings, with their fantastic set of 1/32nd scale model kits, about 2 years ago came out with 3 versions of the Fokker D.VII, Albatross, OAW, and Fokker built. And inside their instructions, they have this panel. And they have this. Decal number 114 goes there. And in the text, they give credit to working with Memorial Flight for a lot of information, though they don't necessarily say what information they got from them. And when you look at the decal sheet closely, which almost takes a microscope to see, gauge 114 is an 8,000 meter altimeter. Now, I've never seen a First War German altimeter mounted in the panel. Doesn't mean that there aren't there. I've got limited sort of, experience looking around. But since there is a nod to Memorial Flight as a source of information, I suspect that this came from them based on their interpretation of what Knowlton has in the panel. So I guess we sort of have art, imitating life.
The unfortunate thing is there's hardly any period photographs of the dashboard of a Fokker D.VII.
So, off to Knowlton to try to figure out what we can do. This is something that struck me, I think, the first time I was there. This is the aft cabin on the starboard or right-hand side of the airplane. It's attaching, it attaches to the fuselage just at the top of the firewall. And what's of note are these 2 clamps or brackets here. The other thing that's notable, not initially, but after you understand the airplane more and appreciate how good the manufacturing was, how exacting the cowls fit together. They're incredibly precise, despite the fact they've been beat up for the last 96 years. They're really well made. Everything is very, very precise. And you come across here and you see this sort of ragged hole cut through. And while at the time I didn't appreciate it because I didn't have enough pieces of the puzzle to put together. But anyway, so we've got this sort of anomaly, 2 clamps that aren't clamping anything. This is the upper wing. We'll sort of forget the sad state of it. The fact is, if I didn't mention before, this aircraft still has well over 90% of the original fabric on the airframe. There are numerous areas that were patched in 1962-63 by the RCAF, but substantially, this is original factory-applied fabric. Now, the upper wing is not Albatross built like the fuselage and the cowls are. This is an OAW wing, and that's been, I've, quote, known that forever because everybody said, oh yes, it's an OAW wing. I verified that for myself in one of my inspections inside the pulley access doors. You can actually see the OAW stamp on the wing rib. Every wing rib, of the 2 sets of wing ribs I've seen from original wing ribs from D.VIIs, they all are stamped to tell you who made them and et cetera, et cetera. So we know it's an OAW wing. If we
look a little closer at it, it's hard to see in that photo, we see this at a series of rib locations on the leading edge, is that there are these holes. And they're pretty uniform all the way down the starboard wing, going from the end strut up to the center section of the airplane. So, a little more research. Here's a lovely photo of a group of Canadian Air Force personnel. We believe this was taken in the UK. Don't know what D.VII they're standing in front of. Don't know who the woman is, like her gloves. But of note is back here is 6810, sitting up in this lineup in a photograph. When we look at this photo a little closer, what do we see? We see a pitot tube on the end strut. We see pressure and static lines running up the strut across the leading edge with aluminum clamp, aluminum clamp, aluminum clamp, aluminum clamp, aluminum clamp, screwed into the leading edge. And then coming down, and oh, hey, look at this. There's little clamps holding those two brackets to the aft cabin of the airplane. So we're going, what would you use a pitot tube for on an airplane? And the hole, which by the way is 4.25 inches in diameter with 6 bolts spaced around it, is exactly the size to put a Mark IV British airspeed indicator into. The one in this little display panel that I put together, that's an American-built copy of the Mark IV. Has the same dimensions, different bolt pattern to it. But we feel, without having any document from the Canadian Air Service or the British services saying that, yes, we installed airspeed indicators on all D7s, once you recognize the pitot tube and you start looking at war trophy D7s, you start seeing pitot tubes all over the place.
And this was because Fokker D7s came from the factory without an airspeed indicator. I guess the Germans figured if you needed an airspeed indicator, you shouldn't be flying the airplane.
Very good.
But the British, you know how the British are, they can't fly them without an airspeed indicator. So the British felt like they had to put one in it.
Actually, that's an extremely good point Fred just made, because if you look at the panel for any contemporary British airplane, and I guess most of the contemporaries for this would be the Camel and the SE-5, there's instruments everywhere. I mean, they're just jammed packed. The Fokkers that I've seen and the original panels that I've seen just lack a huge amount of things.
But the Fokker triplane did not even have a dashboard in it. It just had a few instruments hanging on the tubes in the fuselage. So this was a step up for Fokker design.
This is the deluxe version.
Yeah.
So we feel that we've resolved what this was about. By the way, this has absolutely zero impact on the Fantasy of Flight's aircraft because it's not going to have this installed. But it's huge relief to the local Transport Canada aviation inspectors who don't want me flying an airplane without an airspeed. So, and just to go further, here's the photo that was at the very beginning, and if you look at it closely, you can see the pitot. By the way, we have no idea if the wing that's in this photo is the same one that's on the Knowlton airplane right now. But we just like the fact that there's a pitot sitting there. So Fred gets to talk about this one more than me, though he did make me pick that up.
Well, Mike, my customer supplied this radiator, and it was built not necessarily by a experienced radiator manufacturer, and it was sent to me to use on the airplane. As it turns out, we're not using it. It's about twice as heavy as it's supposed to be. An original radiator would have weighed somewhere around 50 pounds. This radiator weighs almost 100 pounds. So we're making another radiator for it. But that took us on another search for radiator drawings for Fokker D7, which there are some out there. Of course, none of them are original drawings, but we're trying to figure out what the radiator should look like for a Fokker D7. So John can take you on that journey.
Okay. Well, the first thing is Fred has a friend who is an experienced, very high-level restore of classic cars. And by classic, I'm talking pre-1930 vehicles. And he has considerable experience working with historic radiators and cooling systems in general. And he was asked his opinion of the radiator, and immediately he was confused by some things. I mean, when we look at this radiator, just so that you understand, it is lying on its side. The reason for the cutout like this and the angle is looking exaggerated because of how the photograph was taken. But that sits up and over the nose of the crankcase for the airplane. And it's slightly V-shaped, which you'll see in later photographs. Of note is that there is a crisp, clean line in the sheet metal running around there. You can see this metal, which is approximately 20 millimeters wide, sort of running around the perimeter of the whole thing. This component here is the header tank for it, and this is the filler neck. The filler neck is not complete because there is a cap on it, but there's nothing here to attach a cap to, and it came without a cap. And just peeking around the corner is the inlet. So the inlet, the water flow on the Daimler Mercedes engine is the individual cylinders, each one with its own water jacket, are daisy-chained together. And the outlet from the coolant flows from the top of the A cylinder, or the one at the very front of the motor, and it goes into the radiator. And the way everything fits together, the inlet to the radiator and the output from the cylinder is maybe 10 millimeters distance between the two of them. It's a very close fit in the airframe. So anyways, so we have this, but when we're talking to the cooling expert, his concern was with this is that while it's a wonderful core and everything, there's no way to water that you put in here to flow across the top of the core and go down that side. If you see here and here, those are two outlets because they're the two low points in the radiator. And they combine together into a Y-shaped collector underneath, two pipes going out that run underneath the crankcase on the starboard side and into the water pump at the rear of the engine. So we start looking for drawings. And oh, by the way, this is the radiator. It's better view of what that radiator looks like. This is installed in the airplane.
We just installed it in the airplane for test running the engine.
To actually make sure that the engine would run. No, that's not what I wanted to do. So, computer expert, I need to click on the image. Can't find the mouse.
Can't find the mouse.
Well, I'm using, oh, there it is. Yeah, see? Told you that's because it was a finger. It's not a mouse. Okay, you don't get to see that. There's not quite sure what's happened. We actually had a video in there of the engine running on our first engine run of the airplane. And amazingly, if you actually follow Daimler's handbook for running the engine, the thing starts up right away. So it is, the point of it in relationship to the radiator is that this radiator actually works, but basically what was happening is the water is coming in here and going straight down and out this side, and not really using that part of the core. So start looking for drawings. The largest drawing I had, because it's full size, was drawn by Jim Moro sometime in the 1960s. He put together a set of drawings for the D.VII which were never completed. But when you're looking for radiator drawings, this was the first one that I had. This is not necessarily for the airframe we're doing. I should let you know, by the way, is that the radiators were not manufactured by Fokker or the other primary constructors. They were built by specialist companies and provided to the airframe manufacturers. If you look up here in this view going down, there's different lengths of core in there, which indicates that this was actually off a longer engine than the Mercedes D.III, which would infer a BMW engine or an engine of that type, the BMW 3A motor, which is physically longer. not by a lot, but still physically longer, and this would give clearance to the front of the engine inside the core. We look at the drawing. This is one of those wonderful drawings where all the metric measurements have been converted into about 27 decimal places of imperial units, just to confuse things. But they actually convert back to correctly for the core size. And what we can do is we can see the core going across. It goes from that edge to that edge. It goes down to here, behind this sheet metal, et cetera. You can see the nice crisp lines on the shape of it, which is very much like the radiator supplied by the client. Dick Fuuka did a set of drawings for the detailed drawings for a Fokker D.VII based on the airframe that was acquired by the Fokker Foundation. You can correct me on that one, Dave. I think it was the Fokker Foundation, wasn't it? Yeah. And what he did is being a draftsman, he did a lot of detailed drawings of components of the airplane, leaving the airframe alone. So this is his radiator drawing, which substantially agrees with the other one. We've got the same crisp lines to it. It's got an offset filler, which is actually identical to what's on the Knowlton airplane, and to the Smithsonian's U-10. No, U-10 has the one in the center. But it gives no detail of the coring or any tankage or anything else inside. These are drawings done by Don Dodson that were published in World War I Aero, I believe, in the 1980s, shortly before he passed away. And on first look by me, they seem to be substantially what the other drawings were. At that time, I didn't recognize a few details which were hard to see in here, is that this drawing, if you see here, where all the others had a crisp, clean corner, this has a radius in the corner, which turned out to be more important than I thought. My last trip to Knowlton, they graciously allowed me to move all the cowls off all the sheet metal off the front of the airplane, so that we could see things that hadn't seen the light of day for probably since 1962, and certainly weren't recorded at the time. What we're doing in this photo is we're looking straight down on the radiator. This is the air pump. It's a horizontal two-piston air pump. Front of the airplane that away. This is the inlet to the radiator, and unlike the client-supplied one, or like the drawings we have, you can see the inlet, while being a diameter to match the outlet on the cylinder, hugely widens out. The other thing is that all the drawings show that these pipes are pipes. They're like mandrel bent brass piping. This is made out of two stampings. Could be machine stamped, could be hand formed. It's very simple. But they're joined together, and they have a horizontal seam where they were soldered together, and then a wide flange, which is about 15 millimeters, where they get soldered onto the header tank. A better view, looking at the same thing. And this is where all these little details start showing up that sometimes you wonder, what the heck is that for? So here's the filler. You can see this, the inlet. You see the seam on it. This wing nut helps attach the cowling piece that completes the shape over here on the airplane. There are actually two other cowl nuts just off the photo down below, which is still causing some problem. But something we've never seen in a drawing, which is this. There is actually a flange in the sheet metal running all the way across the top of that side. And as I discovered when I finally got all the sheet metal off, the reason being is that to retain the front piece of sheet metal, which is getting all the prop blast and directly into the airstream, it actually has a second piece of metal flush riveted onto the inside that works as a pair of fingers that sit over that flange to help to retain the part. It's a very neat, nice little thing that they've done. That wasn't on the client-supplied radiator, and sort of a tough thing to add on after the fact. The other part, and unfortunately this isn't a great photo, doesn't show it well, we're looking down the port side of the radiator, the left-hand side from the top down, and what we can see is some of the radius in that corner. It's about a 15 millimeter radius in the sheet metal that's running around on the vertical sides of the radiator. And while it just seems like sort of a nice touch, didn't I make this nicely? There is an importance to it, and this is the importance. Well, all the tubes are flush on the front of the radiator. They all overhang the shell on the back. All the way around, top, bottom, all the sides. They're projecting about 2 to 3 millimeters beyond, and they're not flush with it. Combined with the radius at the front, that would infer that there are no tubes inside the sheet metal as was shown in the previous drawing. If there's no tube inside the sheet metal, all of a sudden we've got the tankage on the side, on the top, and on the bottom that the radiator expert said you needed to make the darn thing work. And by the way, I'm tapping the tank to see if it sounds hollow, which it certainly does. Mind you, it's empty. So we've now been able to take this and a lot more detailed information we picked up from the radiator, and it's now gone off to somebody who is manufacturing radiators. Are they going to say Fred on them?
No.
Oh, okay.
Say D7.
They're going to see D7, yeah. Fred's been thinking of starting up sort of like a post-secondary school for this, based on the techniques that used by Reinhold Platz and Anthony Fokker, and I understand he's going to call it Fock You. But
See, I feel like Ed McMahon.
no. This is our third of 4 examples we're going to show you, and this is sort of something I was leading up to earlier in this dialogue. And how do you create something that is authentic when there is nothing to base it on? For the airplane that Fred is building, it is an early Fokker-built aircraft using an exhaust system that is completely cowled in, except for here, where there are 2 pipes exiting through the cheek cowl on the airplane. This photograph, by the way, came from Wingnut Wings website, and if you're interested in D7s, or actually any of the aircraft, if you go to the Wingnut Wings website, and they have a model of that airplane, if you dig into that model, they have an archive of historic photographs of every one of the aircraft that they produce a model for. There are some wonderful images that a lot of people have never seen anywhere else before. And this is one of them. This is actually a detail of a line of aircraft, of D7s under maintenance. And it was the best photograph we could find that showed the general arrangement of this style of exhaust. So this is an original, what most people would consider standard Fokker D7 exhaust. It's the high-level exiting exhaust, one of the ones that was apparently produced to help counter that unfortunate challenge they were having with the tightly cowled exhaust of excessive heat, fabric firewalls, or wind baffles, and exploding incendiary ammunition, which was unfortunate because the ammunition container is directly behind the fuel tank. But what's of interest about this is how this was manufactured. So if somebody went to me or anybody who builds custom cars or airplanes or anything else and says, build me an exhaust, the first thing you go out is you measure out what the lengths are supposed to be, general diagram, and then you get a bunch of mandrel bent tubing to be able to form it from, probably in increasing sizes as you go along. So, you know, hey, this is pretty simple. I got 6 tubes with different radius bends in them, and I weld them into a collector. This exhaust is built by Willy Bomb, and it's the same manufacturer of the exhaust manifold that's on the Knowlton D7, and I believe the same manufacturer that's on, oh sorry, U10. It looks like this, but doesn't have a data plate on it. Somebody souvenired the data plate at some point, which happens to a lot of these items. So this is how it's made. It's not made out of tubes. And I'm actually stealing Fred's thunder here. Do you want to talk about this, Fred?
Oh, yeah, I can.
I'll flip pages for you.
Okay, like John said, you'd expect them to be made out of a round tube that was bent with a mandrel, but these are actually pressings. It's kind of like a clamshell design where you make a tube from two halves, which was a little bit surprising. So knowing that that was kind of like the way they made exhaust systems, when I decided to make the low-level exhaust system, like John explained in the earlier photo, I used these type of techniques. You can also see in this photograph, there's a weld going circumferentially around the tube. So that's it.
I'm now Vanna White.
Okay. Not that one. Go in just a little bit right there. There's a weld going around the tube. So they actually had little stubs welded on them, and that doesn't make a lot of sense if you're just studying these things. But if you build them, whenever you weld something, and these were all gas welded, which is how I build airplanes. I use acetylene welding. The heat really distorts these thin-walled exhaust systems, and so by making them modular like this, you can minimize the amount of distortion that ends up in the final product, and so that's why they were made that way.
We'll do the quick.
Well, this is the original. This picture here is the picture of the exhaust that I'm making for the Fantasy of Flight airplane. So you can see the construction techniques are the same. And when I was done welding it up, it fit the engine actually quite well for all of the amount of heat that it took to weld this thing together. And so there you can see the straight lengths were made with round tubes, and the curved pieces were made from clamshells, basically. And so I ended up with what I believe is an exhaust system without having anything but pictures to go by, an exhaust system that would be representative of the manufacturing techniques used in World War I. And after you do this a long time, you sometimes think that the best you can do is make something that's representative. Do you know if it's exact? You don't, and there's no way to prove it. But you just try to make it as representative as possible of the originals.
And there's always a hope that an original one of these will appear one day, and of course completely validate what's been done here. Yeah. By the way, we never could find a drawing, but we did find a sketch. And Ildeflug had one of their numerous documents showed the various designs of exhaust systems in rudimentary sketch form for various motors and who the manufacturers of them were. Not sure what the purpose of the document was. I don't know if you were going to go out to build an airplane one day and decided on this motor that you looked through the list and said, oh, I'll give Willy Bomb a call and have him make an exhaust system for me. But nothing with any kind of detail. So I had a chat with Mr. Kilduff about this. Because he wrote a book about Carl Degelow that's caused us all sorts of head scratching. But we'll get into Mr. Degelow. What'd you say, Charlie? Later. As we're working on the airplane, specifically we're working on the cooling system, and we're working with the fuel system and the balancing the air pressure and the fuel flow and trying to figure out how everything impacts on it. We recognize that there's like a major problem with the Fokker D.VII and its instrumentation, is that there are no engine instruments. There's nothing related to engine, outside of the performance shown by the tachometer. There's really nothing there. Knowlton has a single air pressure gauge in it. When we come to U-10, U-10 has two air pressure gauges, which still personally baffles me because I don't know why you need two separate gauges, one for the main tank and one for the secondary tank, because you're only using one at a time, and one of the valves in the system specifically directs the airflow from the hand pump or the motor-driven compressor to the tank in question.
But there is a French document from 1918 that indicates that there were 2 air pressure gauges in some aircraft. We'll go, what we saw, once again, this is U-10 at the Smithsonian, and Carl Bobrow here and other staff members were extremely hospitable to Fred and I and a couple of others who went down there last year. And we got to go through a collection of items that had been removed from U-10 during restoration. The surprise to me was this. This is the original instrument panel. And I'm frankly a little baffled about why it was removed and a copy was made, because it's in very good condition, except for a little bit of oil staining on the back. What we're looking at it is from the back, so I should probably point out a couple of things. Some of them are unique. The small holes on the bottom are where the valves go for the fuel and the air pressure system. This hole on the side, which is actually the right-hand side of the pilot, is a panel-mounted greaser for the water pump on the motor. The greaser needs to be used very frequently. Approximately every 10 minutes you need to put a quarter turn of the greaser into the water pump to keep everything working properly. These are the 2 instrument holes, which in U-10 have air pressure gauges in them. This hole with the 3 screw holes around it is the magneto switch. And down here is the hand start magneto. And this is something I'd never seen before, is that the reason, if you remember the photo I showed of Knowlton where it had a small round hole for the connector block on the back of the hand start magneto, in this one the whole magneto has been mounted behind the panel, slightly protruding through, which is why you have the outline of the complete hand start magneto. When we looked at it, we also noticed that there was these fascinating stampings in there. I apologize that they're so small, hard to see. And you know, there's a fish, and we wondered if it was some kind of Christian symbolism related to the war or something. Turns out that no, it's actually the manufacturer's brand who manufactured the plywood. I don't know if Fred's going to get a rubber stamp like that made to stamp on the back of the Fantasy of Flights panel, but you know, it's something for somebody in the future to aspire to. Dick Fuuka's drawings, once again made with an airplane, quote, an original airplane, though with an unknown history, substantially unknown history, has same basic layout as U-10, different valving style, but as far as instruments, but it's got 1 air pressure gauge and 1 oil pressure gauge, which to me makes a little more sense than 2 air pressure gauges, because at least gives you some idea of what's happening to the motor. And then the last drawing, which, Memorial Flight. Memorial Flight has done a combination of U-10 and Dick Fuuka, is that it's got the Albatross late Fokker dash panel layout minus the interesting gauge. But instead of 2 air pressure, it's got 1 air pressure and 1 oil pressure gauge, which once again, from the perspective of basically anything post-1920, makes sense to have something that indicates what's happening with the motor. Then we come to Jim Keeger's drawings, which were his original set. His drawings, by the way, are extremely good for almost any of the aircraft that he does. The challenge with using Mr. Keeger's drawings is that there's virtually no provenance to them. You don't know where the information came from. You start seeing patterns, you go, oh, well, this thing, if that's exactly the dimensions Dick Fuuka has in one of his drawings, or this dimension looks, it's drawn even the way Charles Cash did it, but you can't be 100% sure. And with the OAW panel, he's played extremely safe. He hasn't dimensioned or labeled anything. But he is still showing 2 holes, 2 instrument holes in the panel up here. So the reason this is a dilemma to us is because of the motor. The Fokker radiator on the right-hand side has a manually operated shutter that will allow you to control, to a small degree, the amount of heat exchange happening through the radiator.
That was common on World War I airplanes. They didn't have thermostats that would automatically regulate the cooling system. The pilot had to maintain the water pressure or temperature, and So, like, for instance, the most obvious example is the SPAD 7, the SPAD 13. They have those shutters on the front that the pilot could open and close depending on whether the water needed to be cooler or warmer. On Fokker D7, the shutter is actually behind the radiator. Where did I start? The World War I airplanes, engines, and water-cooled engines did not have thermostats in them to control the temperature of the water. The pilot had to do it himself. And the examples you see most obvious are like on these, like the SPAD 7 and the SPAD 13. They have the shutters in front of the radiator, and the pilot will open and close them periodically to control the temperature of the water. So among other things in flight, he had to watch his water temperature. Now it's not obvious on the Fokker D7 because the shutter is behind the radiator, so you really can't see it. But there is a shutter there, and so that's what the pilot uses to control the water temperature. The problem that we are struggling with is we cannot find evidence on any of these airplanes or any of these drawings or any of these photographs of a water temperature gauge. It had to be there because why would you have a shutter? You know, if the pilot needed to know what the coolant temperature was, he had to have a water temperature gauge somewhere, but we just absolutely cannot find one anywhere. So this is kind of like some of the deductions we're going through right now.
So I'll add into this that Daimler, in their operating manual for the D3 and D3A engine, say that it's recommended that the coolant temperature be kept below 75 degrees centigrade and absolutely never over 80 degrees centigrade. Now, if I can find it in my notes, we'll get back to Carl Degelow. Carl Degelow, in his book, there is a quote from him where he talks about flying his Fokker D7 after a bullet graze repair to the radiator was done. Down here.
Like Karnak, but
there we are. Yeah. So actually, I should say that so the book, by the way, is Germany's Last Night of the Air by Peter Kilduff. But what Carl Degelow says is that during the test flight, quote, there was erratic wavering of the needle on the temperature gauge. So we've got a pilot saying that the temperature gauge needle was quivering, which is interesting because other aircraft using that engine, such as the Albatross D3 and D5, who were using the Mercedes engine, had a thermometer type gauge directly in the pilot's line of sight in the line that is returning from the radiator back to the motor, which is generally the recommended position. You want it in the return line out of the rad so you know how cool the stuff actually is going in.
In fact, you can see that gauge in the Halberstadt out here in the World War I section. If you look at the piping coming out of the wing-mounted radiator, you can see that little thermometer. It just kind of looks like the thermometer you have outside the window of your kitchen to know what the outside air temperature is. But it's a little thermometer sitting up in the water line, in the return water line from the radiator. So, you know, other manufacturers had some way of telling what the temperature was in the water, but you know, so far we can't find anything in the Fokker D7 except this little line from Peter Kilduff's book, which tells us that there had to be one somewhere, and we're still trying to figure out, and we're still wondering if it's maybe in that hole in the upper left-hand side of this particular dashboard layout.
So the end result of this is that we're asking everybody in the audience to help us with our research. So if anybody, seriously, I mean, you are the people, I'm a large chunk of people who spend a huge amount of time involved in research and investigation and just gaining knowledge about First War aviation. So if anybody has any information, if anybody has ever seen a water temperature gauge, German water temperature gauge from World War I, has a photograph,
or anything else, or comes across something, please contact us, because we just don't know. We just can't find anything beyond circumstantial evidence that there should be a gauge as opposed to a thermometer in the aircraft. So that's our cry for help. So a couple of final thoughts. I mean, for us, with what we've been doing specifically with this airplane, our feeling is that original artifacts, primary evidence, if you will, are the best sources of information when you're trying to build an exacting reproduction of something.
By the way, that's the way they spell artifacts in Canada.
Now, you know, my comment to that is usually they do call it English. Anyways, so we have found with this specific airplane that the Knowlton airplane has been a huge benefit, but as I said, with the caveat that it is one aircraft with 8 different serial numbers so far, maybe more. We've found at least 8 different serial numbers on it. But because of its history, we've got reasonable confidence in that what we're dealing with is either a new made something, a copy, a bodge, or whatever, or it's an original part that came from Germany in 1918. But it's, the more you see, the more you understand how problems were resolved at the time. And the more you can understand how they approached problems and how they manufactured things and worked with materials, the more you actually build to get literally a physical feeling for how some of these things were done, the easier it is to actually sort of be in the mindset to sort of channel the era, if you will, to be able to produce something. There are times where we can't get an answer from anywhere. We can't find a photograph, we can't find a document, we can't find what we want in the D.VII, and really what we've come down to is we've sort of devolved to this point. And surprisingly, we've done that a few times and then gone back to Knowlton to check something and found out, by gosh, that's what they actually did.
Okay, Karnak and Magnificent will answer your questions and then tell you what the answer is.
So, guys, with those 2 hypothetical instruments, wouldn't there be something on the motor that would serve as evidence as to whether or not those instruments were there? For instance, wouldn't there be a takeoff on the motor where you would have to have a probe to tell you what the water temperature is to relay back to the instrument on the panel?
Problem is there's too much evidence. So when we're talking about the water temperature gauge, there's a potential fitting on the filler neck. There's a potential filling on the inlet neck. There's a fitting just after the Y on the collector pipes from the 2 pipes that come down from the radiator and collect together to go to the water pump. There's 3 locations, once again, on the Knowlton airplane. And by the way, the same locations from what we've been able to see through the archive of U-10, at least 2 of those 3 are on U-10 as well. The problem is those areas that look like they'd be set up for putting a threaded fitting for a capillary gauge, for instance, have plugs in them, as if they've never had anything fitted to them. It's not that there's just an empty hole left in it because somebody swiped the gauge 50 years ago or something. It looks like it came from the factory with a plug in place. Yeah. Same thing with oil pressure gauges. There's all sorts of places, Dave will tell you on the motor, where you could tap off to get oil pressure, and which apparently people are doing.
But you don't see, you don't ever see any evidence of it anywhere.
Yes, sir. In a white shirt. Sorry.
Yeah, I'm still an active Air Force flyer, and forgive me for thinking safety. I understand that the design philosophy is to build something as exact and detailed to the contemporary technology. Nevertheless, presumably you want to fly this airplane, and that calls to mind some safety issues. And who gets in this airplane, and are they qualified to put it through its paces? I guess my question is, do you accept the notion that by building it as exactly as you can, you were going to build an airplane by contemporary standards, even if they were robust at the time, nevertheless is not a safe airplane to fly in the contemporary world? And how do you kind of balance that? Because airplanes crash, and this one is more likely to have failures based on your hard work and accuracy.
I can speak to that one because I'm with an organization that crashed the D.VII. So I can talk about the D.VII specifically, and don't have it with me, but a photograph of the airplane. Basically what happened is it lost power just after takeoff at Geneseo, New York. There's a river just off the end of the runway. Didn't quite clear the row of trees on the far side of the river, clipped one branch, which we actually have at the organization on display, and basically did a flat spin from about 80 feet straight down. And the airplane, if in a black and white image, it looks like 1,000 pictures you saw of shot down D.VIIs where it's crumpled in all the same places. The landing gear collapsed the way Fokker designed it to collapse. Despite the fact that airframe wasn't built with the original materials, the design still performed the way it was supposed to, which is to basically allow the gear to break off in that kind of shearing sort of incident to save the fuselage. I'm not sure if they were trying to save the pilot, but to save the fuselage. Once again, I'm not going to talk about other aircraft. In relationship to the D.VII, as far as flying the airplane, there's nothing with building authentically that is a challenge to that. There are lap and shoulder belts installed in the airplane in a way that would be approved nowadays. You know, you've got the foibles of working with, you know, a 90-plus-year-old motor, but the motor itself is hugely robust, very smooth, and there's no reason that it should be any less reliable with the appropriate maintenance than an 0235.
But to further answer your question, I think, in my experience, that most of the people that get in these airplanes understand what they're up against, and they're taking the chance that things might not go as well as they'd like them to go. But you know, it's like the old thing where, you know, you can make your airplane too heavy to fly if you make it too safe or too crash proof. Most guys are willing to accept the risk in exchange for authenticity.
Just a quick follow-up. Does your authenticity, and it'll show my ignorance of ATF and automatic weapons, does your authenticity extend to armament? Are you permitted to use weapons on these airplanes?
To my knowledge, there's nothing in the FAA regulations that say you can't have a gun on an airplane. I mean, a mounted gun. Obviously, in an airliner, you can't have a gun, but I don't know of any regulation that says you can't have a gun on air, and there probably is no regulation because nobody's done it yet. You have a comment, sir?
Sorry, there is a regulation about firing the gun.
You can't fly with a live active gun.
You say you can't?
Cannot.
Okay.
That's an instrument.
Fred, can I ask you a question? What is your favorite airplane?
Camel. Southwest Camel.
We know that John likes, but we didn't hear what yours favorite.
The Southwest Camel.
Southwest Camel. Thank you.
Sorry, in the blue shirt?
Oh, Bill's got a question. Go ahead. I was just wondering, for Fred, I don't want to know what you're getting paid to build the airplane, but is it a time and materials type arrangement, or is it a fixed fee? Like, you come up with an amount you thought it was going to cost, or as you find that these things are welded a certain way, it's going to take you this amount of hours and this much materials, so it gets added to the total?
For most commissions, the customer wants to know about how much he's going to pay for the airplane in advance, so it's mostly at the quote on everything first. And I was thinking about getting myself a raise and going to work for McDonald's down the road.
I've been told that we've now taken up half of Mike's speaking time. We can take one more question. You've been very patient.
I'll ask you later.
Okay. Yes, sir.
Just as a note, I have a friend who's a recent member of this organization who used to be an A&P, and I tried to get him to come to this thing today, and he wouldn't or couldn't. So, do you guys have anything written, or is there a website or something that replicates what you've just shown us?
No, but I understand that many of these talks are going to be posted by the league online. They're filming some of these, so I'm sure they've run out of data space by now for our talk.
Smile.
Thank you very much.
Thanks.